This lecture is being brought to you in part by the generous gifts of these sponsors.
Good evening, everybody, and thank you for coming here and listening to me, and for Ken for inviting me, and Brent as well. Brent was my PhD student, also my master's student before that, and I think that she was the most brilliant student, but besides that, then she remained after the PhD. We worked together for several years in Italy, in Padua, the University of Padua. And I think that the way I would describe our scientific collaboration is that we really had a lot of fun, which is, we laughed a lot, but we laughed not about things that, I don't know, people laugh. We laughed about, what we were discovering together, what the innovation that we were doing together. So it was really, I think, the best way to do innovation, to produce new results, both theoretically, experimentally, and so on. So it was really a great period of time to work together then. So today I'm going to talk about some of these issues that have to do with AI. Artificial intelligence, as you know, is very pervasive in our everyday life. Since it is so pervasive, it raises some ethical issues and considerations. So that's why you see so much talking about AI and AI ethics now and not in the past, while AI has been around for a very long time, more than 60 years. So, and that's why also, many companies and also in academia, you see many positions that are related to AI ethics. So, for example, my position is at IBM that, it's a big corporation, but decided that they needed a person that could be multidisciplinary, talking, being an expert of AI, but also talking to other disciplines and other experts that are more, that have more, competence in understanding the impact on technology on people and society, and understanding the issues that can be in this impact. So, well, just something that I'm sure you read every day in online and on, newspapers and magazines about AI. Some of these titles are interesting and they talk about real issues and real capabilities, but some of them are kind of a bit stretched, like exaggerated on one side or another one. So, and they tend to generate excessive fears or excessive trust into the technology if you're not careful about knowing exactly what the technology can give you. But here, you read everywhere about this, and you also see in academia, for example, that these courses on AI, they get more and more students every year. And also in the scientific community, we see also conferences about, scientific conferences about AI. They get more and more papers submitted to this conference. So, for example, I'm in charge of the next global AI conference. It's going to be in February in New York. We got, like the deadline was a week ago, we got 10,000 papers submitted to the conference. Then we're going to choose. Usually these conferences are very selective, so we choose less than 20% of the papers that are selected. But, so you can imagine we have more than 6,000 people involved in reading these papers, judging them, trying to help and understand which one to select. So it's really, a big increase on the number and the quality of people that are interested in contributing to this technology. And of course, AI is, many companies have woken up and they say, okay, what can AI, since it's so powerful, what can AI do for me? And so there are a lot of studies that try to understand how and in which way AI can be useful for the companies. Of course, companies are very different. There are big corporations like IBM, there are small startups, there are companies with very different business models. So AI can mean and can can give a very different contribution to these various companies, whether to do better the things that the company is already doing, or also to try to invent something new that the company can do with this technology. So there are many, many applications right now of AI. Basically, whatever you do, since you wake up in the morning until you go to bed at night, basically it's powered by some form of AI. So here are just some applications, but every app that you use on your phone, basically it has AI inside. When you search on the web, when you use the social media, when you use your credit cards, when you take a picture, all these activities are really powered by some form of AI. So I give you just some examples here, but I'm sure you have used many of those. And then examples, for example, that IBM is focused on, whether it's healthcare, compliance, marketing, customer care, and so on. So each company has its own business model and its own kind of application that is good at. And in particular here, you may have seen in the title, I call it AI ethics for enterprise AI. I will tell you what I mean by that. And that's the kind of AI that IBM and companies like IBM are interested in, which maybe is slightly different than other companies like, for example, the social media companies or the Google or the other things that provide services directly to people rather than providing AI that can be used in other companies that then provide services. So first, a little bit of clarity about what is this idea of intelligence, artificial intelligence. I mean, we don't even know what it means for a human being to be intelligent, so let alone for a machine. And so this term, which has been started being used in 1956, so already more than 60 years, it's a bit misleading sometimes because it makes us think that these machines can be intelligent, whatever, and people don't, different people have different ideas of what it means to be intelligent. So over the years, the researchers have said, okay, let's say that a machine is intelligent if it has the capability to understand what's the best action or the best plan to put together to solve a certain problem that I give to the machine. So I, as a person, I give the machine a problem, and then the machine understands what the best thing to do to solve it. And so in some sense, this is the capability to do problem solving, it's called sometimes rationality, to understand what's the best action to solve a problem. And that's one form of intelligence. It doesn't cover all the aspects of intelligence that we may think in a human being, but it's something that people have worked on. And in some sense, this brought the research community to develop what we call narrow AI, meaning, okay, so then if this is the idea of intelligence that we have in mind for a machine, then it means that the machines are very narrow in being able to solve well specific problems. So a machine that can find the best route from here, from this city to the one where I want to go, or a machine that can interpret, understand what's in an image, or so very narrow problems. And the machine in those narrow problems is very, very good. And usually is even better than human beings. But it doesn't have what we would call human-like intelligence, which is more horizontal. Maybe we are less good in each one of these narrow problem-solving scenarios, but we are more, can learn from one scenario to understand how to solve problems in another scenario, and so on. So the machine still don't have this kind of artificial general intelligence that sometimes is called like that. So, we will see that over the talk that the machines have this form of intelligence that again is narrow, specific, even superhuman in these specificities, but then it has some strange behavior that I'll try to convey a little bit better. So, but the idea is really this is the kind of intelligence that we're talking about. Over the years, so from the 50s to now, the scientific development of this community has gone through a lot of summers and winters, they're usually called. Summers of AI is when, a lot of promises, a lot of hopes, and some delivery, of these promises, and so a lot of funding, a lot of positions, a lot of excitement. These are the summer. But then, in the past, usually these summers have been followed by the so-called winters of AI, where these promises maybe were a bit too exaggerated. So people say, but then it's not matching the promises what I get from this technology. So then the funding became less, and then position, and then it was even kind of strange to say I'm working in AI. So sometimes during the years I saw people not saying that they were working in AI, because you can rephrase what you do in some other way that without using AI. So I'm old enough to have seen some of these winters and summers. So now we are in a very hot summer, but we believe that this summer not necessarily has to followed by a winter, because there is the convergence of various factors that was not existing before that allows us to say, well, maybe this summer is different than the previous summers, but we have to be careful, because if we follow the hype, or if we say things that are not really realistic, if you don't communicate well as experts the real capabilities and limitations of the technology, then people are going to have hopes that then are not going to be matched, and then it's difficult to not have a kind of a fall or even a winter after the summer. So you see here that over the years, at the beginning, most of the AI that was around was AI of a kind that you would say symbolic reasoning, symbolic and reasoning, which means you take a problem, a human being or the scientific community understood how to solve that problem. So not the machine, but the human beings. And then they also understood how to codify the steps to solve that problem. And then once this is done, they say, okay, now we tell the machine what we understood how to solve the problem. Now the machine solves it because I'm telling exactly all the steps to solve the problem. So that was the kind of AI that for a long time was around, and it could solve many, many different problems, and it works well even now in many situations. But then lately, some other form of AI came about, which is called machine learning, or more recently, deep learning, which is just one form of machine learning, where instead the idea is different. There are some problems that I, as a human being, I don't even know how to formalize, and let alone, I cannot understand how to give you exactly the sequence of steps to solve it. So what I do, I give to the machine a lot of examples of problem and solution, problem, solution, problem, solution. And then I just codify into the machine a kind of generic algorithm, generic recipe on how to take these examples and try to generalize, and so understand how to solve the problem even for situations that were not in the examples, okay? And this is the idea of machine learning. Very simplified. This is the idea of what's so-called supervised machine. But anyway, the details are not important. This is the idea of this other form of AI. So let's give you an example of the first kind of AI, the symbolic reasoning. So the algorithm that I mentioned before, like the GPS, the Google Maps that you use to understand how to go from here to there, this is based on an algorithm which is in every AI textbook, which is called A*, which is no name that doesn't say anything, but basically it's an algorithm. Somebody, a community of researchers said, okay, this is the problem. The input of the problem is the place where I am, the place where I want to go, and the maps of all the streets that are from here to there. So the solution, this is the input, and the solution is the best route from here to there, found in as fast way as possible, okay? And such that it's the optimal route. I cannot just give a random route from here to there. So in this case, this approach of just human beings codifying the problem, finding the right algorithm, and then giving it to the machine works well because the input and the output are very clear. and they don't change over time, so then it's always like that. You have where you are, where you want to go, and the maps. And so if everything is clear, then these algorithms work well all the time. And so this is how it works in your Google Maps or whatever GPS system you want to use. But there are other situations where this is not possible, as I said. And so, for example, the typical example is when you want to teach a machine how to recognize whether an image you want the machine to recognize what animal is contained in an image. Like in this case, for example, it can be a cat or a dog or a horse or a monkey. Okay? So so in this case, I don't know how to formalize the problem in order to cover all possible situations, because each one of these animals may appear in many different ways, upside down, whatever, in many different light conditions. So I do not know how to exactly formalize the input in the machine, and I don't even know to tell the machines exactly what are the steps. Step 1, step 2, step 3. You have to do this and then this and this, such that if the machine follows these steps, then for sure he can give the right, correct response. So what do I do? Well, I say, okay, I don't know how to tell you how to solve this problem, but I'll just give you a lot of examples. So I give you a lot of pictures, and for each picture I'll tell you, this is a cat, if it's a cat, this is a dog, if it's a dog, so the right answer, okay? And then I give to the machine a way, as I said before, to minimize the error of doing this solution to this problem, even with images that I never shown in the set of examples. And this picture that you see there in the middle is called the neural net. It's basically something where you give the input from the left, and the machine gives you the answer here. And every time the machine gives an answer, like in this case, for example, the input is an image of a horse, the machine gives an answer, and I tell the machine, this is not right. You're telling me it's a monkey, but it's right. So the machine goes back to this network here, and adapts the network, adapts some numbers that are around in the network, such that the error next time is smaller and smaller and smaller. Until I think, by testing the machine on some other examples that I've never shown before, until I say, okay, now the error of the machine is small enough, now it's ready to be used. And this structure in the middle, as I said, is called neural network, because in some sense, but vague sense, is inspired from the structure of our brain. So these small balls are like inspired by our neurons. And these lines that you see here are like the connection between our neurons. And basically, the inspiration is because each one of these written as a ball here, each one is some piece of code that can do something very, very simple, but once you connect all them together, they can do even complicated things. So each one, again, performs a very, very simple piece of computation, but then it's connected to a lot of other neurons from the previous layers. Each one is a layer. You see 1, 2, 3, 4, 5 layers in this network. And then what this single piece that does something very simple can change doing these things, because it can consider the input, which is given by these other neurons that is attached to, by changing some parameter over this thing. So these connections, they tell that neuron how much he has to take into account what the other neurons are telling him. And by changing this how much, so these weights that are over there, then you can adapt the behavior of each one of these neurons, so you adapt the behavior of the whole overall neural net. So it may be complicated, but it's not. But anyway, it's the idea that really you are not telling the machines what to do exactly, but you're giving them the examples that show what it means to solve that problem. Of course, in the first approach that I showed you, I, as a human being, I had to do a lot of work, because I had to understand how to solve the problem. Otherwise, the machine wouldn't solve the problem. I had to understand all the recipe, the steps to solve the problem before being able to tell the machines, okay, this is how you solve the problem. In this, kind of AI, I don't have to do that, also because I don't know how to do that. But I have to give something else to the machine, which is all those examples, millions and millions of examples. So I have to find enough examples and label them with the right, correct answer. So in both cases, there is knowledge, information that are given to the human being, to the machine. It's not that the machine can solve problems by itself in neither of these two situations. So, as I said, okay, in the case of machine learning, yes, you have to give all these examples, but then you have a machine that is very flexible. So the machine does not need the input exactly in a certain form. It can deal with the uncertainty of the real world. While in the first kind of AI, this is not true. It's very rigid and so on. It works well when it doesn't matter, the flexibility. But in this case, the machine is very flexible because it can really deal with the uncertainty of the real world. So now, why this form of AI, machine learning, you may have seen before in the slide with the timeline, was around since the 80s. But for a long time, it didn't work well. So you may have used, like even 10 years ago, I don't know, some voice commands, or like with your telephone, they were not working well. They were, you would need a lot of training with your voice, and then after a long training, then it was never understanding what you were saying, and so on. So now, there is no need of training. Now it works very, very well, okay? Why is that? Why is that these machine learning techniques that were around, and now they are working so well, and especially for those tasks that have to do with the interpretation of images, voice, text, those tasks where you need a lot of uncertainty. You will have a lot of uncertainty. And the reason is that because now we really have all the ingredients that are needed to make this machine learning work. And the ingredients are, first of all, better and better algorithms, okay? But the other two are even more important. First, one of them is the availability of all those examples. We said that without the examples, these algorithms do not work. And so you need a lot of examples. So where do these examples come from? Well, they come from us. Because we publish, look how many things we post on YouTube, on Facebook, and all the social media. Every time we post on something on social media, whether it's text, whether it's an image or something, this is all taken as training set. It's called, this set of examples that is used for training machines and make them better and better and understanding images, text, and so on. So now we have a lot of data to be used as examples for these algorithms, and this data has been increasing exponentially over time. So more and more, very, very fast growing amount of data. And also the first ingredient is that even if you had all this data, which in the 80s we did not have because we did not have social media, we did not have the internet, but even if you had all that data, you needed computers that were powerful enough and fast enough to be able to look at all this data, analyze all this data, find correlation all this data. And we didn't have them. So now we do have them because also the computational power and the speed of the computers have been growing exponentially over time, doubling every 2 weeks with a law that started in 1965. So, so much that, as I said, in some of these problems, like image understanding, text interpretation, and so on, machines now are even better than human beings. So here, for example, it shows over the years, this is the performance, this is the error rate of machines that try to interpret what is in an image, like the example that I gave you before. And already in 2015, you see that it goes below, the error that we make. So you see the machines are even superhuman capabilities in very narrow problems. Okay, so these are the two main approaches to AI, but AI actually is much more complex than that. It has a lot of sub-disciplines. So here I give you a picture where I show you a little bit that there are a lot of different techniques and even many more than what I wrote here. So this is AI, you see. It contains machine learning, it contains symbolic reasoning, but each one of them contains a lot of different techniques here, a lot of different techniques there. It is all part of computer science, okay? And it has to do with robotics, but robotics is not really a sub-part of it, because of course robotics has a lot to do with not just the reasoning and the learning capabilities of a machine, but also what is possible given the physical pieces of the machines. Like a robot has some capabilities, and I can write whatever code I want, but if the physical pieces of machines don't allow to do those things, he will not be able to do those things. So robotics is something that of course has to do with AI, because a robot has to have embedded inside the reasoning and learning capabilities to plan what to do, the actions and so on. But it also goes around outside AI and outside computer science that has to do with physics, with engineering, and many other disciplines. Okay, so the next step is to understand that artificial intelligence is also a term that is a bit misleading, because it makes you think that we are going to build an intelligent, or whatever it is, intelligent, like in the sense that I said before, but kind of that is going to work by itself, separated from us, and it's going to do everything in an autonomous way by itself, which in some tasks maybe is true, but in general, still, and I think for a long time, human beings and machines are very complementary in the capabilities that we have. We are much better than machines at creativity, emotion, social interaction, asking the right questions, and so on. Machines are much better at other things, like finding hidden correlations in huge amounts of data, computational power, and many others. So it's only by the putting together these two forms of capabilities, or intelligence if you want to call it, that you get really the best results. So this is an example that of a study that was done in 2016 that shows that for the task of discovering breast cancer from images and data about patients, they used the best AI system at the time, and the best AI system had an error rate of 7.5%. So 8 times out of 100 they were making a mistake. So then they used the best pathologists to do that, the same problem, and they were making a mistake 3 or 4 times, 3.5% of the time. Okay? And then they asked the machines and the doctor to work together. So the doctors were doing their job, but supported by the capabilities of the machines, and then the error rate went down to 0.5%. So basically it disappeared. So it means that really these two kind of intelligence, in some sense, they were really so complementary that together they could do much better than each one of them alone. So, and this brings us to this idea of enterprise AI. So enterprise AI, as I said, is the kind of AI that you need when you want to use this technology not to deliver services like social media or an app or that goes to individuals, but you want to deliver this technology into a company, like whether it's a hospital or a bank, in order to help the professionals in that environment to do better their job, to make better decisions, more informed decisions, and so on. So if you are in that frame of mind, then the kind of capabilities that you need in that AI is very specific to that environment. So first of all, you want AI that can interact and work in team together with human beings. You don't want AI that works by itself, because the final decision maker usually is a human being, but he wants to be supported by this technology. And second, you want this interaction to be very easy for the human being. You don't want the machine to adapt, you don't want the human being to adapt to the machine, you want the other way around. So it means that the machine has to be very good at interpreting natural language, the way we speak, the way we interact naturally. And also, sometimes in these environments, you don't have really a lot of data. So, for example, you want to solve a new problem in a bank. Well, if it's a new problem, by definition, you don't have a lot of examples of how it was solved. And also, so differently, instead of what you have on Google and Facebook, you have huge amounts of data that you don't have shortage of data, but in some infrastructure you don't have a lot of data, so you have to understand how to make machine learn to solve problem without having a lot of data. And also you have a lot of domain knowledge, like a doctor. Now he studies these big books, about the techniques and so on. So you have a lot of domain knowledge that in some way has to be codified, and you cannot just teach a machine the techniques to do things just by examples. So you have to understand how to tell the machine this domain knowledge. So you have to combine these two basic approaches of AI, the learning part and the reasoning part. You have to combine them together. So so here is some cartoonish way of looking at this. So in enterprise AI, you have a company that produces a piece of AI that gets delivered to a very complex infrastructure, like a hospital, for example. And then the doctor uses in his operation, the doctor of any other professional inside the hospital, uses this piece of AI to do his job and deliver some better service to the final user, which is the patient. But the patient is not alone. The patient also is an infrastructure where the family, the nurses, and everybody else. So you have to take into consideration all the pieces of this infrastructure and these communities, rather than saying, okay, what's the service that I want to deliver to the single individual, like you would do for a social media and so on. So it's a very complex environment. So, and there are a lot of current capabilities of AI that can be useful in that environment, but one has to be careful to understand that there are also a lot of limitations still in AI. It's not that the technology is done, that these 10,000 submissions to the conference should tell you that really people are trying to overcome the current limitations. And these are the current limitations. So first of all, machines do not yet have this idea that we rely so much about when we interact with other human beings, which is common sense reasoning, which means to know how the world functions. Like we are not experts in physics. Those of us that are not experts in physics, we don't need to be experts in physics to know that if I take this and I just open my hand, it goes to fall down, or many other things. So we know how the world functions, and we rely on this information to avoid telling each other all sorts of small details, But the machine does not know at the beginning, scratch, does not know how this common sense reasoning, does not have this capability. And unfortunately, so far, we couldn't understand really how to embed this significant form of common sense reasoning to a machine. And this is definitely needed if you want the machine to interact naturally with the human being. Then, as I said, this combination of learning and reasoning, natural language understanding. I'll show you an example where we have a lot of machines that you may have seen that understand what we say, understand what we write, but understand in some very specific form. So I would not call it understanding. I would call it they can interpret what we say or what we write for the purpose of that specific application. But I would not call it a real understanding. In fact, you don't see any AI system that can have a very long dialogue with you. Usually there is a question answering system. You ask a question, how is the weather today? Alexa responds, or whatever, Siri or whatever else. But if you start doing a dialogue, every time you have to start from scratch. The next question is a new iteration. So, and the reason is not because these companies don't want to give you a dialogue machine. It's because it's not easy, and still machines don't have the capability, because to entertain a dialogue, you really have to understand what the other person is telling you in the previous iteration of the dialogue. But also it has some limitations related to ethics. For example, when machines interact with human beings, yes, we can say, okay, the final decision maker is the human being supported by this technology. Fine. So whatever ethical consideration you have in the decision that the human is going to make It's the human decision, it's not the machine. But if you want the machine to support this decision-making process of that human being, the machine has to be aware of the properties of the ethical principles that that human being has to follow. So if it's a doctor, he has the Hippocratic Oath, or if it's another professional, he has a business conduct guidelines and so on. So the machine who is helping this professional has to know these code of conducts, these ethical principles, and has to follow them while supporting the decision making of that human being, because otherwise it can give you suggestions that go completely, tangential and completely in the opposite direction that those code of conducts. And so you may have a lot of properties that you want this technology to have. One of them, for example, is fairness. So if you want the machines to understand what it means to have a good or a bad decision, fairness is one of the properties that you want to have. In many situations, you expect human beings to be fair in their decision. And so if you want the machines to help these human beings, they have to know what it means to make decision in a fair way, meaning not discriminating different groups or of people or whatever impacted in the impacted community. Another thing is explainability. Explainability is a big topic of research right now, and it means that if you want this doctor, for example, to trust and to follow the recommendation that the machine is giving him, for example, the machine could say, for this patient, I think this therapy is the best one. And maybe it's not the therapy that the doctor had in mind. Maybe he was leaning towards a different therapy, less invasive maybe, whatever. So in order to get the best out of this suggestion for the machine, the doctor has to trust that really the machine, to trust that the machine is giving his suggestion that are really the best one for that patient. So the doctor has to be able to ask the so-called why question. Why are you telling me that that therapy is the best one and not the one that I have in mind? How did you reach that conclusion that that therapy is the best one? So the machine has to be able to explain how he got to that decision. And while this explanation is kind of easy in the first form of AI, the one based on symbolic reasoning, because in some sense, you remember, in that kind of AI, I tell the machine, these are the steps to do. So in some sense, if the machine got to a certain decision, it's easy to trace back so where the decision started, being conceived. But in the other form of AI, the machine learning, the one based on the example, is not that easy to trace back to what made the machine suggest a certain decision. So in that case, it's many people in the research community that try to embed this capability into machine learning approaches as well, because without this capability, we think that people in the long run will not trust the machine, and so they will not adopt it, and they will not be able to get also the good suggestion that they give. I'll give you the robustness, I'll give you some examples later. There's another property that we have, but I'll give you an example of why I say that natural language understanding is still a big limitation for machine. And I'll give you with an example of a challenge that is posed to machines every year, and it's called the Vinegar Schema Challenge, from the name of a pioneer in AI. And this challenge poses a very simple question. For us, it seems like a very simple question to a machine. So it just asks the machine to do a very simple anaphora resolution. It gives the machine certain sentences. They all have this structure. So the structure is, for example, the box did not fit in the suitcase because it was too small or too large. Now the question is, what was it, too small or too large? So for us, it's very easy to say. If you wrote small, it means that the suitcase was too small. If you wrote large, it means that the box was too large. So for us, this resolution of this what it refers to, is very, very simple. Well, the best teams all over the world that participate to this challenge, they have less than 60% accuracy. Okay? Almost like 50%, which is like a flip of a coin. So this tells you that these people are the best brains, around the world. So this tells you how difficult it is for a machine to really understand what we are saying in terms of natural language, But this doesn't mean the machines are very good at dealing with natural language, for example, in translating the language, or doing all sorts of very useful things for using natural language, but very narrow. And so you'll find, for example, if you use Google Translate, you can translate from one language to any other language, almost with the perfect quality, most of the times. But then the machine does not really know what he has been translating. It does not know the meaning of of those sentences. So a lot of capabilities in interpreting natural languages, but not much about deep understanding. And this shows an example of that. So what are the main ethics issues that people brainstorm about? So the first one, first of all, again, AI ethics. Do people care about AI ethics? Well, look at this graph. This graph shows, the trend, over the years of the news coverage of AI and ethics over the years. And look at how much it has grown. And so you say, why it has grown so much? And of course, it's reasonable that it has grown because, as I said, now the machines are so pervasive in our everyday life, and they make all sorts of decisions, recommendations, suggestions, and so on. Then people start asking, wait a minute, so then do they know what it means to make a good decision or not? What is the impact on our life, and so on? So these AI ethics issues are now very considered and discussed much more than before, because when before we couldn't use those machine learning techniques that allow the machine to be positioned really in the real world. Before, in some sense, the machine could be delivered only in very controlled environments, where in some sense the environment had to adapt to the machine. Now the machines can be delivered also in a much less controlled environment. They can deal with pictures, videos, text, and so on. They can do many more things, and so the use is much more pervasive. So what are the main ethics issues? The first one is, okay, machines make decision or give me recommendation for decision. So which values are they following? Am I sure that they follow my same values, my same principles, my same values in getting to those decisions and to those recommendations? So whether it's fairness, ethical guidelines, principles, moral values, code of conduct, whatever, but I want to make sure that they follow those values. And not only I want the developers, want to convince the developers to put the right values in the machines, but also when I use them, I want to make sure that I know that they are following those values, and there comes the explainability that I told you before. And then the next one is, okay, I understand that these machines, especially those based on machine learning, they need a lot of data. And of course, so I have to give data to get better machines that behave better, they have less error. And I also have to give my data, because I know that by giving my data, I get more personalized services. And this is good. But what happens to my data? Who is taking my data? Who is giving it to? Where is the data storage? Who owns my data? Do I retain control of my data, or is somebody else using the data in a way that I cannot control and it's not desirable for me? The next topic is this topic of responsibility. So if the machine makes a mistake, and I'll tell you later why a machine may make a mistake, if a machine makes a mistake, who should I talk to have some, who is responsible for that? To get some compensation, some redress. So who is accountable for this behavior that maybe impacted me in a negative way? Maybe I asked for a loan, the bank told me no because the algorithm said no. And so I said, okay, but maybe that was a mistake of the machine. I want to ask the why question, so the explainability part. But also, I may want to say, okay, at the end, if we discover that it was a mistake of the machines, I need to understand who to ask for accountability. And of course, this topic of accountability and maybe is less of an issue, and also explainability is less of an issue in some form of AI, like the consumer AI of the social media, the search over the web, and so on. I'm not going to ask, if you didn't suggest if Amazon didn't suggest to buy books that I really like, I'm not going to ask, who is accountable for not suggesting the right books. But if I go to a bank and then my loan request is not accepted, or if I go to the hospital and the therapy is really impacted negatively my health, then yes. Or if I go into the judicial system and some decision is made that impacts me negatively, then yes, in those domains, I want to know who is accountable. And then, of course, all the impact on society. This technology is so pervasive, and so and in some cases it may create addiction. It can manipulate us to do things that maybe not even in a conscious way we are doing just because the technology is manipulating us. It impacts in the way we live. We spend hours with our apps every day. It impacts the way we interact with other human beings, and it impacts our children. How do they grow up in a place, in an environment where they mostly interact with machines rather than human beings, sometimes. And also, it may also create additional inequalities between different kinds of people, and it may also be used in ways that is not the intended way, or is not the best way to use it. And the reason why we cannot just stop the technology, we have to look at the uses in some times, because AI is, many techniques in AI, they have this so-called dual use. So the same technology that allows a farmer, maybe in Africa, to understand where to put the drops of water, so that with the little water that he has, he can get the better, crop, is exactly the same technology that then can be used maybe in other situations that maybe are less desirable, or maybe not. I don't know. We have to understand what really uses of these techniques are intended, are appropriate, or not. So there are many people that discuss these issues and try to find solutions. And the solutions are of many kinds. First, there are technological solutions. So how do we make sure, as AI developers, how do we make sure that the machine that we deliver, that piece of AI that we deliver in the real world, have the right properties? They can explain the decision, they are not biased, so they have some form of fairness, and they are secure, so they cannot be attacked, and they are robust enough, and so on. But also there are many other initiatives that try to find solutions of other kinds in order to direct the technology in the best direction. So for example, you will find around a lot of principles for the beneficial AI, or guidelines, best practices, incentives, standards, certificates, auditing systems. So all sorts of different, and even laws and regulations. But in some sense, laws and regulations are usually the last thing that you want to do, because first of all, laws are very difficult and long to change. If you do a law, then to change it, it takes a long time, and the technology is evolving very, very rapidly. And also, laws are very inflexible. So they have say things, or either they're very inflexible, or they're kind of vague and they don't really apply to many situations. So there are really a lot of other tools, and then of course there are also a lot of enablers that are very important. One of which is education. Education of everybody, education of the students that are studying in STEM, so technology, engineers, computer scientists, and so on. They need to be aware not just of how to advance the technology, but also how to make sure that while advancing the technology, you take care of these properties and ethical issues that the technology brings with it. But also education of everybody, for example, of policymakers. The policymakers can make big disasters if they have a strange idea of what the technology can or cannot do, or whatever. So really, they have to have a very realistic idea of the current technology to be able to understand what is the best way to harness it, with the tools that they have in their hands. Here, this picture is a list, a part of a list that was put together very recently by an assistant professor at University of Boulder, Colorado, which lists AI or tech ethics courses in the university, mostly in the United States, but it's crowdsourced, meaning that anybody can go there and add the courses, and so far yesterday, as of yesterday, had already 238 entries. So you see that fortunately there are a lot of universities that understand that tech students needs to be aware of these issues as well, to find this technical or also non-technical solution, but anyway, to be aware of those issues. And the last thing here, it says that, well, it's clear that in order to find the right solution to those issues, and even to identify the right issues, you need to work, AI experts need to work together with experts of many other disciplines. They cannot do the thing by themselves. Because in order, for example, one of the first time that the issue of bias was raised was raised because of an algorithm that the US judicial system was using to assess the probability of recidivism. And that was a machine learning based algorithm that was trained with examples that came from historical data. Okay, and so that nobody thought about is it going to be biased? No, I'm looking at the data of the past, and I'm going to use it as example, and now the algorithm is going to be used and following what happened in the past. But somebody else, not the AI people, not tech people, somebody else went and looked at the behavior of that algorithm, and they saw that the algorithm was making some mistakes, and they saw that the mistakes were very different in quantity depending on different ethnicity of the people. For some ethnicity, there were mistakes in one direction, so it was giving you a much lower risk than reality. For other ethnicity, it was a mistake, but in the opposite direction, so it was giving a much higher risk than what it was in reality. But again, this was something, and then the tech people said, oh, okay, so now we have to fix, and this was true not just in that example, but to say that this didn't come out from the scientific and the tech community. It came out from other people, from the social science community that says that, let's go and look and let's tell the tech people they need to fix it. So that's why without a multidisciplinary effort, we cannot really solve and address those problems. But besides multidisciplinarity, you also need and I'll tell you later, a multi-stakeholder approach. Meaning not only you have to work with philosophers, psychologists, sociologists, economists, and so on, but you also need to work with the communities that will be impacted by the decision made by these machines together with human beings. Because, for example, just to talk about the notion of fairness, well, there are so many different notions of fairness. Okay? Fairness in some domain could mean giving exactly the same amount of resources to everybody. In another domain, it could mean giving the same opportunity to get resources to everybody. And it depends on the different scenarios. So you have really to work together with the community that will be impacted by the decision to understand what's the right notion of fairness for that solution, for that piece of AI. And without that, you may use a notion of fairness that is not the right one, and so it's not the one that is going to be useful in that case. All these initiatives that are existing already around these issues, most of them, they focus on this idea of trust. They say, how can I trust the technology? How can I trust those that produce the technology? And how can I trust those that are going to regulate the technology in some form or another one? So many of these worldwide initiatives really are around the notion of trust. And trust is a big concern also for the companies that want to use AI, because they are going to use AI, but they say, well, but we need to trust the technology in order to get the technology embedded into our operations. So well, I'll skip you this, but what is it needed, for example, to trust a decision for the technology? At IBM, we said, okay, let's make it simple. We want to trust the technology. We want to deliver a technology to our clients that can be trusted. So let's break down this idea of trust, which can be vague, into some concrete requirements. And we said, okay, these are the 4 main things. First of all, the thing of values, values like fairness and other ones, how do we make sure that technology has the right values for that problem, for that community, and so on. The second one is the technology easy to understand, so explainability that I mentioned before. The third one is the technology robust, so makes very few errors, as few as possible. Okay? And the fourth one, is it accountable? So how do we make sure that we are transparent about what we did to build that technology? So that's why we have this approach that has these 4 pillars, and then we do research, business, all centered around these 4 pillars. So let's give you some idea of each one of them. So the first one, as I said, is fairness. So now you say, why should these machine learning approaches, why should they be biased? Why don't they make decisions that are fair? Well, because we are biased. And we are the ones providing the examples to these machine learning approaches. So this guy wrote down all possible kinds of bias that we have when we make decisions. Most of them unconsciously, of course, so we don't do it intentionally. But since we have so many unconscious kind of bias, it's easy for developers that are like normal human beings to inject this bias into whatever design choices, especially the training set that they use for the examples for the machine. I'll give you an example of how much the training set, so the examples that are given to a machine learning approach, impacts the decision of the machine. So here is an example from Google Translate. So what I did, I took some sentences, these 2 sentences here, and I translated them into Turkish. And the reason why I translated into Turkish, because I wanted the machine to forget about the gender. In Turkish, there is no gender. So the he and the she is forgotten. Okay? So I took these Turkish sentences, and now I asked the machine to translate it into English. And you see that the machine, now here the machine does not know the gender, so the machine had to guess the gender of the nurse and to guess the gender of the doctor. And how did it guess this gender? Well, it looked at the training data. And since the training data obviously had many more women nurses and doctors, men, and so on, that's what the machine said, well, you told me with your examples that the vast majority of nurses are women, so I will put a she, because that's my highest probability of being correct. And the same for a doctor. So the training data, that was not balanced enough, whatever, it impacted the decision of the machine in choosing this gender. Of course, this is not a very high-stake decision, but you can imagine that also in more important decision, the same way the training data can impact the decision of the machine. So to understand, I'll tell you later about that. So the next one is explainability. Explainability, again, is to be able to have answers to the why question. No? There are some places in the world, which is where I come from, which is Europe, where there is a law that is in effect already since a year ago, which is called the General Data Protection Regulation, that says that the data subject, which is the human being, providing the data, has certain rights. And one of the rights is to be able to have an explanation if there is a decision that impacted him or her in his life. Okay? So here the General Data Regulation says you have the right to be provided with meaningful information about the logic involved in the decision, if the decision was made by an algorithm. So that means that this is in some sense required by law in that part of the world, but even if there are parts of the world where it's not required by law, as I told you before, there are some environments where if you don't have this capability to explain, then sooner or later these machines will not be adopted, will not be trusted and not adopted. So you will not get even the positive things. And of course, explanation is a particularly complex thing because for the same decision, you may want to give many different explanations for the same decision because this explanation, they get to different different kinds of human beings. For example, for a decision like we said before, like in suggesting a certain therapy for a patient, you may want to give a certain explanation to the patient, a certain explanation to the doctor using some detailed healthcare medical terminology, or you want to give even an explanation to the developer. They may want to understand why is the machine telling this, and use it like a debugging tool in some sense. So you have very different target audiences for the explanations, even for one decision. The next one is robustness. So robustness means you want as few mistakes as possible. So now the question is, why would you design a machine that makes mistakes? Design a machine that does not make mistakes. And then the problem is solved. And in some sense, with the first kind of AI, that's the approach. If you, researcher, you, developer, have understood how to solve the problem, and this is a correct algorithm that finds the solution to the problem, then the machine should not make mistake, unless the developer put a bug in the code in some way. But the machine should not make mistakes. So the GPS or the Google Maps and so on never makes mistakes. I mean, right? But, so in principle, it never makes mistakes because that algorithm, it has been proved that theoretically that is optimal. Given the input, it gives you the optimal solution to the problem. Okay? But with machine learning, it's not that simple, because now we are not telling the machines, do this and then this and then this and this, and you're sure to solve the problem in an optimal way. No, we tell the examples, and the machine is kind of free to understand how to generalize from these examples, which in some sense, this creativity, this freedom is good because the machine can find solutions that maybe we would not have found. But it can also go astray into finding some paths that are not actually solving the problem and are not desired solutions. So I'll give you some examples here. This is a very famous example of an image. So on the left, you see this image, and is interpreted as a panda, so correctly by a machine, with a certain confidence, because since these machine learning algorithms are all probability based, they cannot tell you for sure this is the result and for sure not. Those give you a level of confidence, probabilities. So this is interpreted as a panda with almost 60% of confidence. So that's fine, that's a correct answer. So, but if you give the machine this image, which to us, it looks exactly the same, right? But to the machine, it doesn't look the same, and in fact, it's not the same, because this is obtained by combining this original image with a noise image, with this image, but it doesn't matter, but it changes some pixels in the machine, but in a way that we, with our eye, do not see. This, the same algorithm that can interpret correctly this one, does not interpret correctly this one. It says it's a gibbon with 99.3% of confidence. Okay? And the reason is that we tend to think that machines see images or read text in the same way that we do, but of course they don't. For a machine, an image is just a sequence of pixels, and this pixel is like a combination of three colors. So it's not seeing that image in the same way that we see it. So the machine can also make mistakes that for us are like, how can he make this mistake? Because for us it's like for a human being, it would not be a reasonable mistake to make. If a human being can see this one, that is a panda, it can also see that this one is a panda. So there are mistakes that machines do that are very unexpected for us, and even though machines, as I've shown before, they can make less mistakes than human beings, so they can be more accurate than human beings. Sometimes these mistakes can be kind of unexpected and strange for us. This is another example. So this is interpreted correctly. Oh, that's the ostrich that I know that here IHMC has ostrich robots as well. This is interpreted correctly, but these ones are not. And to us, they all look the same, really. But only few pixels have been changed, and the algorithm is fooled. Okay? And of course, this is important because so that we understand that machines can make strange mistakes, so we don't have to anthropomorphize machines, thinking that they make the same kind of mistakes that we do. But it's also important because, unfortunately, this mechanism of changing few pixels and having the machine interpreted in a different way can also be used as a way of attacking a machine learning algorithm and fooling the machines in making a certain decision rather than other ones from some attackers. So these are some other example of these kinds of attacks. So this machine does not interpret correctly. So this is stop sign, but by putting some stickers on the stop sign, the machine interprets it as another sign. Also the speed limit, also this one here is interpreted as this woman just because it has these glasses on. So this stop sign is interpreted as speed limit and so on. And of course, this is the most worrisome example. So here you see this is the original image. So you have a street with some pedestrian, crossing the street, and this is the interpretation of the machine, which is correct. There is some people passing by, but this is the what's so-called adversarial example, meaning take this image, make some tweaks in the pixels, and you get this one, which again to us it looks exactly the same, but the machine now interprets it as if the pedestrians are not there. So you can imagine that if this algorithm is inside a self-driving car, then it would not see the pedestrians. So again, it's very, very important, and there are a lot of people trying to understand how to use or counterattack these adversarial examples, and because of two things. Because you have to we need to understand how to avoid these strange mistakes from machines, but also how to avoid the machines are fooled by these mechanisms. The first one is the transparency. Okay, when we buy food or other things, so medicines and so on, we have a lot of information about the way, the properties of that medicine or of that food. Or sometimes, I don't know, more in Europe, maybe here than here, but anyway. So we have a lot of information. When we buy, I don't know, a toy, you have the intended or unintended, age range for the toy and so on. For machine learning or AI algorithms, when we deliver, most of the time we just say, okay, that's 99% accurate. That's it, nothing else. So you say, okay, so it's just 1% error, so I'm fine, let's use it. But we don't communicate a lot about, what properties we put into those machines. What values, what fairness, for example, what bias testing has been done, what kind of training data has been put together. And this is not to say that a corporation, of course, have to release the data in the algorithm. They're not going to release the data in the algorithm. This is proprietary. But they should at least release information about the design choices that were made or the answers to these questions. What is the appropriate use of this machine? What kind of testing data and training data did you use? What kind of test for bias did you do, and so on. So all sorts of information that is not disclosing confidential information and proprietary information, but is needed for whoever is going to use that piece of AI to really understand what it can be used for and what it cannot be used for, and what to expect, what are the real capabilities of limitation and properties of that technology. So at IBM, we have this holistic approach. We do a little everything, we do things in research, we do things with the policymakers, we do things with the business units, so to try to really follow these 4 pillars that I showed you. And we also work internally and externally to make sure, that we work with everybody, not just inside the tech company like IBM, but also outside with all the other stakeholders. So here are some examples of things that we do internally. So this is the notion of AI fact sheet that I just told you, how to collect a lot of information about the design choices. These 3 are open source toolkits that we put together to understand, together with the rest of the community, because it's open source, everybody can contribute, the issues of fairness, robustness, and explainability. Okay? And there are, in this website, you find tutorials, you find definitions of these notions, you find code for the algorithm, you find training data, you find, you can play around, you see how it works, one algorithm rather than another one, and so on. And then here we have, well, some principles. We have a program to actually apply AI for social good purposes. We use relationship with external foundations to get data to resolve issues like, I don't know, the Zika virus or the opioid crisis, things that society are of societal importance. And then here, this is something different because this is really to educate developers. So we wrote this booklet that is called the Everyday Ethics Guide for these designer developers, because again, these people that are our developers, but also developers in any other company producing AI, they've been studying, the way to do their job without being exposed to these ideas of fairness, explainability, transparency, and so on. So they really need to be educated about that, and they need to ask themselves questions about these issues every day during the various phases, from the conception of the product to the delivery of the product. They have to be aware, because as we said before, they are normal human beings. They have a lot of unconscious biases, and they need to be careful about not injecting them into the system. So this booklet, which is but for every developer available, is really helping them being aware of that. And the last one here is all this partnership that we have externally to the company to really work with everybody else, including the civil society and the impacted communities, but also impacted communities, to understand these issues, identify the issues, and resolve them at the best way. One of these initiatives is called the Partnership on AI that we funded in 2016. Already almost 3 years ago, and it started from 6 companies. They are the companies that you see here, and the idea was that we realized that not one single company could address and resolve and understand these ethical issues by itself. So we needed to get together to understand what would be the best practices to deliver AI in the most beneficial way for people and for societies. But we said, okay, not only we have to put together a bunch of companies, but we have to put together companies with everybody else. So that's why now, from these 6 companies, now we have about 100 partners, of which less than half are companies, and everybody else is universities, research centers, UN agencies, and advocacy group like ACLU, or all sorts of organizations that want to contribute to the understanding of what is the best way to use this technology to improve our life and to solve problems that we don't know yet how to solve. And the last one here that I want to mention is this initiative that we participated in Europe together with the European Commission. So the European Commission put together a group of 52 people from all the disciplines. AI people are less than 10 out of 52 from all the disciplines to understand what it means for AI to be beneficial. And in this case, like in many other initiatives, the emphasis was on trust, like I told you before. So we defined this idea of trustworthy AI with 7 requirements. We released in April of this year the guidelines, ethical guidelines for trustworthy AI, saying this is the kind of AI that we think should be, at least in that case it was in Europe, but it can be extended to other parts of the world and here as well, I think. And then we also released some help for policymakers. We say, okay, these are the recommendations for policies and for investments around trustworthy AI to give to the European Commission, hoping that then the European Commission will pick them up and try to understand how to really develop AI in that region with that thing. But besides the content of these documents that are being delivered by this group, it's, I think, as a nice example of an initiative which is multidisciplinary, multi-stakeholder, and independent. So the European Commission said, you are the group, you work by yourself, we are not interfering, you tell us what to do. And then, of course, they have to make their own decision about how much they pick up, in which way, or whatever. But it was a very independent approach. Okay, so I think I'll stop here and I'll get some questions.
China has indicated that they want to be a world-class leader in AI by 2025. They use AI to spy on their citizens. They give points, and if you don't have enough points, you don't get loans to buy a house, you don't get into school. And I'm sure they don't emphasize ethics too much. So, what's your views on sharing information with them, and if they get ahead of us, and your thoughts on the future of AI with respect to our adversaries?
Yeah. Okay, so it is true that China is becoming every day a much bigger player in AI, both on the business side, like companies, services and so on, and also on the scientific side. In these scientific conferences on AI, now we are at the point that almost 40% of the papers are from Chinese, researchers. Okay, so you understand that, so until a few years ago, they were submitting a lot of papers, but most of them were rejected because they were not high quality enough. Now they really are delivering high quality AI. So it's not just implementing or making concrete things that have been thought somewhere else, like it was until a few years ago, but really innovating themselves. Okay? So it's expected that they will become more and more of a player, not just in making some things real and using them, but also in making innovative things. And the use they do of AI, of course, I mean, when I talk with my colleagues from China, it's very easy for me and for you and maybe for most of us to judge what they do and say, oh my God, they are using AI to, mass surveillance, they have cameras everywhere, and then they do this social score and so on. But they respond to me and say, well, it's very easy for you to judge, but in some sense, two things. One, they say, well, what about your, credit score or whatever other things, which, by the way, you may be used to it, but I come from Europe, and it's a kind of a strange thing for me that we have a credit score. But another thing that they say is that, well, you need to understand that we may have the same values all over the world, but we give different weights to the different values. Like, for example, the value of privacy or the value of individual rights compared to societal harmony and stability and prosperity, for them they give different weights to these values compared to us. We think that our individual rights are the most important thing, and we are not willing to compromise this right to make the society more stable. Say, no, my rights are my rights, and the society, okay, then I will take care of, whatever happens in the society. For them, societal stability and harmony is the most important thing. Okay, so to some of them, they don't see anything wrong with this social score. And for me, it's wrong, right? But I'm saying sometimes it's kind of easy to judge from another culture, but that's why also these initiatives have to be multicultural as well. So the partnership on AI, for example, has partners and companies as well from China, like Baidu, for example, or from Japan, like Sony, for example, because really I think that we need to talk with them and to understand their set of values, why they're doing things in a certain way, and to compare the different points of view. So my approach is to talk with them because it doesn't make sense that you only talk with people that have your same point of view. You also need to talk with people that have a completely different point of view, completely different culture, and you have to accept that in different parts of the world, maybe the same values are given, slightly different, comparative weights. So it's not as black and white, I think, as I saw it. They made me realize that it's not as black and white.
On that note, let's thank our speaker.